Hello my loves! Right, I'm just going to talk to you today about the binomial expansion and which one to use and when. Right, so in your formula book, this is the AQA formula book here, this is AQA, but it'll be similar for most. Right, you're given both formulas. You only need to use the top one if your power, well, you can only use the top one if your power is an integer. Otherwise, use this one, okay? Otherwise, use this second one. Now, pretty much the second one always works. So when you get past first year and you start learning this one, then definitely always use this one, because this works for fractional powers or any rational number, any negative number or anything, okay? The only bit you need really from that first formula up here is this formula here. If you're asked a question with an NCR bit in, one of these NCR type things, then you'll need to use this formula. And these do pop up every now and again, but most of the time you're pretty safe just using this formula, as long as you know how to use it properly. Okay, so in your formula, just be careful. That's not 1.2 on the bottom. That means 1 times 2, or 2 factorial. This one means 1 times 2 times 3 times 4 times blah, 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 all the way up to r. Okay, right. And you might be asking, well, what's the power of r? Well, sorry, what is r? Well, r is just the power of your x term. Because as you can see, powers of x go up all the time. Here, this is really x to the power 0, and this is x to the power 1, x squared, x cubed, and so on. Right, so we're going to use this second formula, this second version of the formula, and we're going to use it to answer, I think it was 1 plus 6x to the power 2/3. Now, this is nice, because you've got a 1, it starts with a 1, so good, that's all good. Wherever we've got an x, we're going to use 6x, and wherever we've got an n, we're going to use 2/3. Okay? So that's all we're going to do, is we're going to work our way along this formula, subbing in those values. So they always start with 1 plus our n value, which is our power here, so that's 2/3. Times our x term, which in this case is 6x, just be careful. And then we do our next term, which is n, which is still 2/3, times n minus 1, be careful, that's minus 1/3, 2/3 minus 1 is minus 1/3, and we work our way along like that. Don't forget, this is a 6x, because in your question you've got 6x, not just x. And this is all over 1 times 2, so it's all over 2. And you continue along in that way. So 2/3 times minus 1/3, subtract 1 from minus 1/3, you get minus 4/3. And as you can see, this is infinite. This will just carry on going forever and ever and ever, unless you've got a positive integer power, in which case it'll just stop. Okay. Oh, what am I doing? Sorry, that should be cubed. Our third term is cubed. And that's all over 1 times 2 times 3, or in other words, 6. So 3 factorial is 6. Right, okay, so carrying on from there, you can sort all these terms out. You don't need to watch me do that. Just be careful here. You're squaring the 6 and the x, so that will be 36x squared. Now my advice would be to work out these fractions first, then times them by this 36 here, then divide by 2 at the end. So make sure you work out all your coefficients on the top first, and then divide by the number at the bottom at the end. Otherwise you might get in a mess with your fractions and so on. Okay, now the other important bit about this formula is this bit here. So it tells you that this formula is valid where the mod of x is less than 1. Okay, but in this question we haven't got x. This is only if you've got just 1x here. Okay, we haven't got 1x, so this is valid for when the mod of 6x is less than 1. So it's a subtle difference, but it's important nonetheless. Okay, so in this case, the mod of x is just going to be less than 1/6 if we divide both sides by 1/6. So what the mod of x actually means is that x is less than 1 and greater than minus 1, because the modulus of minus 1 is just 1. Okay, so this, if we're trying to approximate a number using this expansion, it's telling you that your values of x that you're going to sub in here have got to be less than plus or minus 1/6. Well, basically between minus 1/6 and 1/6. Otherwise, your answer's just going to be completely off the wall. Okay, so just be careful with that. Now, the only time, the next sort of stage up from this is, and we had this question, it asked you to use the binomial expansion to find the first three terms of this formula. Now, this is worth noting, that is your first term. So if it asks for the first three terms, that means we want this term, the x term, and then the x squared term. Okay, so make sure you include that as the first term so you don't waste your time doing things you don't need to. Right, this 8 plus 6x to the power 2/3 is not in the form 1 plus x to the power n. So we need to make it into that form if we're going to use this expansion. Okay, so we want a 1 here, but we've got an 8. So we need to divide by 8. We need to divide this bracket by 8. Okay, so we divide all our terms inside the bracket by 8 and take that 8 outside. Okay, now of course that isn't an 8, it's an 8 to the power 2/3. So we need to make sure we pop that power of 2/3 on that 8. So whatever number you divide by inside this bracket, you need to pop the same power onto that number. Otherwise you're altering the value of it, you see. Okay, so expanding again, 8 to the power 2/3 is just 4. You can put that in your calculator. Simplify where you can. So 6x over 8 is the same as 3x over 4 to the power 2/3. And then off you go. You can substitute this into the formula now. Whenever you've got an x, you're going to replace it with a 3x over 4. And at the end, you're going to multiply the whole thing by 4. Okay, so you start off by saying that's 4 times 1 plus your 3x over 4, so your x term, times n, so it's 1 plus nx. Sorry, I should have put the n first, really, it doesn't really matter. Okay, plus your n times n minus 1 times your x term. Now remember your x term is 3x over 4. That's squared, and that's going all over 2 factorial. Okay. And so you'd work out each of the terms in turn. So that would give you, those 3's will cancel, 2x over 4, so x over 2. This term's going to be negative because we're timesing by minus a third. So we've got 2 over 9, so minus 2/9. Now remember, so far we've got minus 2/9 multiplying these brackets together. Remember here, we've got to square this 3 and this 4 as well. So that's going to be 9 over 16. Work that out, so that's minus an 1/8. And then we're going to divide that by 2, so we've got minus a 16th here. Okay, so we've got minus a 16th of x squared, or minus x squared over 16. Which we know, because we're all clever sausages, then expands to, so we're going to multiply through by 4. 4 times x over 2 gives you 2x. 4 times minus x squared over 16 gives you minus x squared over 4. Oh, all good. Right, this is actually an exam question, by the way. Right, then the last bit says, use your answer to this bit here to work out the value, or to estimate the value of the cube root of 100. And you've got to think to yourself, right, how on earth am I going to use 8 plus 6x to the power 2/3 in this question? Because that looks nothing like the cube root of 100. Or does it? Well, we know that 100 is 10 squared. So I'm going to write 100 as 10 squared. We know that the cube root is the same as the power a third. Now we also know, because we're clever, that our bracket rule tells us we can multiply these powers. So that is the same as 10 to the power 2/3. Now that does look like this bracket now. Whee! This does look like this bracket. Okay, so we can then go ahead now and replace our 8 plus 6x with 10. With 10. Okay, which tells us that 6x is 2, so x is a third. 2 over 6 is a third. And then we can go ahead and substitute that value of a third into our expansion here. So you're going to do 4 plus 2 times a third minus a third squared over 4. And that will give you an approximation, so you'd have to use your wiggly lines, an approximation to the cube root of 100. It's not going to be very accurate. And sort of follow-up questions to this could be, how can you make it more accurate? We'll use more than the first 3 terms and you're going to get more accurate. Okay, we also need to check that this is valid for the value of x equals a third. So, back to that statement that mod of x is less than 1. So this was the actual expansion that we've done here. The actual expansion we're doing is 1 plus 3x over 4. So our x term here is 3x over 4. So this is valid for when the mod of 3x over 4 is less than 1. So to just get x on its own, we're going to multiply by 4 and divide by 3. So bring that 4 up, divide by the 3. So this is valid if the modulus of x is less than 4 thirds. Well, a third is less than 4 thirds. Boom! So this will be valid. Okay, so important things to do, get it in the right form. Make sure when you take this 8 outside here, or whatever number you're dividing by, that you include the power. That's where a lot of people fall over. Check your validity. People fall over a lot there. And just be really, really careful that when you expand these brackets out, you don't do anything silly like ignore the negative. And make sure you're dividing by 2 factorial, 3 factorial for the next one, 6 factorial, and so on. Okay? And when you get part C of the question, where it asks you something that looks completely unrelated to what you've just done, remember, this is all part of the same question. The examiners aren't insane, so there will be some link. So you just need to find that link. Okay, all right. Hope that helps everybody. If it doesn't, give me a shout. Okie dokie, bye-bye.